And welcome everybody. Continuing our look at rational expressions, we're looking at complex fractions today, and we've had two kinds of complex fractions. One of them we've dealt with before. I guess this is the type that we've dealt with before, where we've had like a stack-o-frac situation. All right, so the general look was something like this: stack-o-frac, and what was in here could have been entire polynomials. The other kind that we're going to deal with today is if I have sums or differences of fractions within my fractions. Okay, so something like this, where my giant numerator has a sum of two fractions within it, or a difference of two fractions within it. So these are kind of the two types of complex fractions. Our method for this kind, do you guys remember the method for this? How did I deal with a stack-o-frac?
Multiply by layers.
Yeah, stack-o-frac. The trick was we mult by recip of the denominator, right? And we're going to develop a different strategy for these. I guess I would describe this as sums or diffs of fracs in fracs. I don't know. I just want you guys to be able to recognize these two separate kinds of problems, because we're going to have different strategies for each, and problem recognition is a huge thing for this chapter. So sums and difference of fractions within fractions. So the general approach, but I guess before I go back and write what our step would be, let's do an example, and we'll do it two ways. Suppose I have 1/2 minus 2/3 all over, and let's say I have 1/6 minus, I don't know, 3/4. Maybe I'll make that a plus 3/4 just for fun. Get a positive number in there. So I could do this a little bit PEMDAS-y if I wanted. I could try to break this apart into two, kind of things, where I'll first deal with this portion, like we would have last night, where I would have found the LCD of those two, and I would have then, combined them into a single fraction. And then I would separate this out and find the LCD between these two and combine these into a single fraction. So let's first consider that possibility. So for the numerator, what is the LCD of the numerator?
6.
So LCD of the numerator would be 6, and the LCD of the denominator, that's not official notation, I just made it up. Yeah, perfect, 6 and 4 is 12. For some reason I always want to be like 24, but nope, they both do go into a smaller number, 12. So I would deal with this as like two separate problems, right, where I'd multiply this by the missing part, so that'd be 3 over 3. This I'd multiply by like 2 over 2. This I'd multiply, this one's all set, because that one, already has its LCD. Oh no, nope, I lied. Multiply by 2 over 2, and this one I'd multiply by 3 over 3, right? Because I want to get 12s down here and 6s up there, right? And this looks like it will be a lot of work, right? So I'd have 3/3 minus 4. Nope. Man, I'm making mistakes. Let's see if I can stop that. 3/6. Ugh, there's the word. Minus 4/6. Ugh. And 2/12 plus 9/12. I guess I'll keep working vertically. So now that I have common denominators for those, 3 minus 4 is -1. I guess I could write it as -1 over 6. And 2/12 plus 9/12 is 11/12. Man, that 11 in vinculum looks like a smiley face. Like it's happy. It's happy right there. Like that vinculum's got just enough arch to it that it's like, yeah. And notice what I now have is a stackofrac situation, right? I went from, sums and differences of fractions within fractions to stackofrac. And then I could go about doing this by multiplying by the reciprocal. So negative 1/6 multiplied by 12/11ths. And I guess I'll just finish this horizontally. I could cancel out 6 goes into 6 once and into 12th. 12th twice. Twice it fits in. Yes. Negative 1 times 2 is negative 2, and 1 times 11 is 11. So I'd end up getting my answer. All right? But that is, I think you guys would agree, a lot of work. And good news, I'm going to have a better strategy for you. So this I would describe as almost like a PEMDASy approach, right, where I did 2 separate addition problems or subtraction problems until I get stackofrac, and then I dealt with it using my stackofrac approach. Let me show you a better way. I assure you, my friends, there is a better way. So I'll call this way number 2. Let's see it. 1/2 minus 2/3. Here we go. And this way number 2 is the way that we are going to use. 1/6 plus 3/4. Now, I am allowed to multiply this entire fraction by 1, right? And it won't change it. The Mondo fraction, Wombo maybe fraction. So I could also multiply it by, right, something over itself, and that's a legal move. All right, that's going to be the approach I'm going to do, and what I'm going to do is, that was just a moment ago, frowny face right there. What we're going to do is find the LCD of the denominators. So I'm looking at 2, 3, 4, and 6, all of them. All right, all of the denominators, right? The mini denominators. You know what I'm talking about. So what do 2, 3, 6, and 4 all go into?
12.
Wow, 12 again. I could have sworn it was going to be 24. 12. And what I'm going to do is multiply this fraction by 12 over 12. Now I want to point out, I'm not multiplying the numerator by 12 over 12 and the denominator by 12 over 12, although I would be allowed to do that. I'm just multiplying the jumbo fraction by 12 over 12. And watch what happens next. This is pretty great. So 12 times 1/12 and 12 times that, and then I'll do 12 times these fractions is what I'll end up getting. So let's see. 12 times, 1/2, my bad. 12 divided by 2 is what? 6 times 1 is 6. All right, so I do the division before the multiplication. 12 divided by 3 is 4, multiplied by negative 2 is negative 8. 12 times 1, 6, so 12 divided by 6 is 2, multiplied by 1 is 2. And then 12 divided by 4, 3, and then times 3 is 9. And notice what I've done. I've essentially killed all the fractions in the numerator and denominator. All right? And I want to point out this technique only works for these kinds of problems. And then the ones that we'll be doing next week. But now it's a much simpler problem to work with, I think you'd agree. 6 minus 8 is negative 2. 2 plus 9 is 11. Right? And that ended up feeling a lot more like a single problem as opposed to this, which was like 1, 2, and then 3 problems is what that ended up being like. So it's a much better approach. So could one of you maybe summarize how would you summarize this to someone? What was the technique? What strategy did I use? If you tried to outline what we did. It is a little tricky putting words to it. What did we do? Where did this come from? Right? So I find the LCD of the denominators, and then what do I do?
Multiply the entirety of the numerator and the denominator by the LCD.
Sure. Wow, I like that language. Good. Yeah, perfect. So this will be our strategy. All right. Find LCD of denominis. Denominis. That sounds like that would be the equivalent of White Castle sliders, but for Domino's pizza. Like just sliders pizza. I guess it'd essentially be like pizza on a bagel mini.
I don't know if
I've never been. But denominis. Doesn't it sound like domininis, maybe is what they would call I don't know. But anyways, so then with that LCD, I would mult jumbo frac, maybe. By LCD over LCD. All right, so that's my general approach, and it ends up working a lot better. And I really like patting myself on the back here. I really like having these two different pictures just so you can kind of have your general recognition abilities, right? So you're like, aha, sums and difference of fracs and fracs, right? I want to use this strategy as opposed to stack o frac, which is technically an easier problem. All right, so let's do one of these then. Let's do a fancier one. So what if I have x over x squared minus 1 plus 3 over, let's do x squared plus, let's see, I'm trying to think, 4x plus 3. All over, we'll have 2x over x plus 1, and then minus, let's do 3, I guess again, another 3, over x plus 3. So, might run out of room on this problem. We'll see. So my first thing is, all right, I recognize this as a sum and difference of fracs within a bigger fraction. I need to find the LCD of all of these denominators. For the sake of fitting some space in here, I'm just going to write my stuff right here real quick. What is this factor to be? X plus 1, x minus 1. And what is this one factor to be? X plus 3, x plus 1, right? So the LCD of the denominators looks like, what's that going to be?
X plus 1, x minus 1, and x plus 3.
Yeah. X plus 1, x minus 1, and then x minus 3. Right, and all of these denominators would be able to cancel into that perfectly. Plus 3. Oh, thank you. Yep. Good call. Good call. So I'm going to now multiply the top and bottom. Oh, I just clicked somewhere. There we go. Yeah. By the LCD over the LCD. All right. I don't have that much room there, so. And I'm going to be very careful in the way I do this. All right. So let's see. I multiply the LCD by this. And I'm going to use kind of the same language I did earlier. Before I multiply, I'm going to divide by the numerator. So this big LCD divided by this numerator, what part cancels out? The x plus 1 and the x minus 1. So I'm left with just the x plus 3, right? Which I'd multiply by x. So I'm going to just write x times x plus 3. We'll multiply that out later. I don't want to skip too many steps, I suppose. And now I multiply the LCD by this fraction. So I'm going to divide it by these, and what cancels out? X plus 3 and x plus 1 would cancel, and I'd be left with x minus 1, and I'm multiplying that by the 3. So I'll do plus 3 times x minus 1, and I'll distribute that later. All right, down on the bottom here. Ooh, it's going to be interesting. When I multiply this, what cancels out? The x plus 1. So I'm left with 2x times, I'm going to have x minus 1 and x plus 3. Yikes. And then when I multiply this, the x plus 3's cancel out, and I'm left with negative 3. Let's see. Negative 3 times x plus 1 times x minus 1. And notice I now just have one giant fraction, which I'm going to go through and try to simplify. Now, question, this is a subtlety. Can I do this? It's difficult to know why you can't, a little bit. If this was written all as multiplication, all right, the issue with that is this and this right here. If these were multiplication signs, then I could be like, yeah, I cancel these, and this is awesome, right? And maybe even the 3's somehow, but I can't because of the that plus and minus sign. So I'm actually going to have to distribute everything that I can, combine like terms, and then see if my end result polynomial can be factored further. So let's see if I can do this effectively. So x times x plus 3 is x squared plus 3x. 3 times x minus 1 would be plus 3x minus 3. All over 2x times, I'm going to distribute these two guys first. That'd be x squared plus 2x minus 3 when I combine some like terms. And then I'll distribute these two. That's x squared minus 1. Let's see. So in my numerator, I can now start combining like terms. So that will be x squared plus 6x minus 3 over, and let's see, the denominator, I still have some distributing to do. So that's 2x cubed plus 4x squared minus 6x, right, from distributing that 2x to all of those. And then distribute this negative 3x, the minus sign's going with both of them, so that's negative 3x squared and plus 3. And then I guess I have this question, is x squared plus 6x minus 3 factorable? I might as well start working up there. 1 and 3, do those subtract to be 6? No. And in the denominator, I think I've got like one like term I can combine. And we're getting some sunshine over here finally. X squared plus 6x minus 3 over, and I'll have 2x cubed. Combining my x squareds here, 4x squared and negative 3x squared would be just 1x squared. And then I'd have minus 6x plus 3. And that denominator, we aren't very good at factoring cubes or any polynomials that are bigger than squares. However, I won't have us do this right now. We could technically factor them by doing the p's over q's, Descartes' rule of signs, using a whole bunch of synthetic substitution, figuring out what the zeros are of it, and then the factors would be the x minus those zeros, and I could find like all of the depressed polynomials, and I could break it up into like the most reduced depressed polynomials it had, and I could technically factor it that way. Oddly enough, I think this one might be factorable using factor by grouping. x squared plus 6x minus 3. I think it looks like it might work out. Let's see, where's my mouse at? Here I could yoink out just an x squared, sorry. And here I could factor out a negative 3. And I'd have x squared times 2x plus 1. And minus 3 times, it won't work out. It'll be off by a sign. So I was wrong. Negative 3 times 2x minus 1. Yeah, if that was a plus 1 right here, I could then have factored it to be x squared minus 3 times 2x plus 1. But it didn't work. So it looks like my answer would just be this thing right here. But if it was factorable, I would factor it, and if the numerator was factorable, I would factor it, and then I would just cancel out everything I could. All right? That's what we would do. So, this one was a tricky problem because I had crazy LCD stuff. But the general idea is the same. You find the LCD of the denominators, and you multiply top and bottom by that LCD. Now, the canceling out, I think, is a little bit interesting, and then you just go from there. All right? I think that's enough for this lesson. And then we'll have plenty of time for compañeros trabajo. So, goodbye, Internet world.